operations and aerodynamics. Okay. So when we talk about rotorcraft, I asked you during the fixed wing. Okay. Similarly, during the rotorcraft operations or aerodynamics, I've already told you that in rotorcraft, there is the rotorcrafts are not designed aerodynamics. Only one drone in the entire world I can see which is aerodynamically designed is Phantom 4, Phantom 3 and 4 by DJI. The shape and the design of it. Whereas all rest of the drones are not aerodynamically designed. Even their body is not aerodynamically designed to counteract the wind and all that. Some extent people are trying to design it, but it's very difficult for a rotorcraft, okay, in form of like four rotors, that is quadcopter or hexacopter or octacopter, very difficult to design aerodynamically because the principles on which the rotorcraft flies is different compared to fixed wing, because fixed wing is using your airfoil structure or a wing structure, whereas in rotorcraft you do not have any structure over there, it is just a frame. Okay, so we don't call it as a structure, but it's a frame, quad frame, hexa frame, octa frame. So there is a frame on which the motors are mounted and your rotors are been uh, moving in the directions. So let's see the first some historical information about the UAV. The first historical use of UAV was on 22nd August 1849. The Austrians used balloons measuring 5.7 meters in diameters to launch an attack on Italian city of Venice with an unmanned balloon loaded with explosives. So this was like the first example of UAV, okay, unmanned aerial vehicle. So it was a balloon. So balloon will rise. It will be filled with either hydrogen or helium, and it will rise in the air. And because of the push of the natural air, it will go towards the direction. So there is no control. You are not controlling, but it is just going on its own. So they have designed the balloon in such a way that it will rise in the air. It will go to certain altitude. There are some sandbags were attached so to maintain the weight and all the things of the balloon. If and there were some explosive attached to it with a fuse. So over a particular distance, it will fly and it will reach to the particular location, but that is not still fixed and controlled. Okay, so this is not a successfully flying of UAV. It was only a initial attempt, okay, random attempt to fly the balloon autonomously and do some activity with it. Like they were want to attack the Italian city of Venice. Okay, this was again attempted by Japan also in World War II. They flown lot of such balloons and they were trying to attack the west coast of America, like California, Las Vegas, and everything. Even they were not successful because since the balloons were flying over the Pacific Oceans, lot of time those balloons never has reached the land. I think there was only one or two cases which has successfully reached the land of west coast of America, but there was no casualties around it. Or maximum drones, maximum balloons which Japan has flown, they have lost into the Pacific seas. So it was not a successful attempt also by Japan. But these were initially use cases of unmanned balloons or unmanned aerial vehicle form. Okay, so let's see now the history how the drones got developed. So father of drones is called Dr. Abraham Karim. He was born in Baghdad, later moved to Israel in 1951. He was actually an aeronautical engineer from Tehran, that is Israeli Institute of Technology. He built his first drone using Yom Kippur War for Israeli Air Force. Okay, so whatever that first drone he was built was further redeveloped. So he moved to United States in 1970. He founded a company called Leading System Incorporation and started manufacturing his first enterprise drone known as Albatross. Later on, this drone was acquired by the US Defense and renamed it as Predator. Okay, so whatever today you see, the drone which is being used by a lot of countries, even India has procured these drones from the US, which is Predator, was made by Dr. Abraham Karim, and that's why he was given a title Father of Drones. Okay, so this is just a small history about how drones comes in, but not necessary. See, he has actually created a drone which was fully autonomous and flying on its own. and for a military purposes. But before there were a lot of attempts were done. It's not that he really created, but he created a version which was more stable and more controllable. Okay, and that's why he was given the title Father of Drones. Now let's see what are the components of the rotorcraft. So basic drone view, types of multi-rotor drones, quadcopter anatomy and terminology, inner electronics and drones, and applications. So this topic is more important from a perspective because we are going to get licensed on this. Okay, this version. So you should know your quadcopter thoroughly, quadcopter or hexacopter drones thoroughly. Okay, so what is drone? Drone is an aerial, ground, or underwater vehicle without human pilot on board. So it can be a quadcopter, hexacopter, or octocopter, or it could be a ground vehicle also where it is moving autonomously. It is moving autonomously. Lot of now things are being getting developed for defense also, which are moving autonomously also. There was a robot which was developed for delivery, like how we have designed a drone for delivery of your parcel. Similarly, in US also, similarly ground vehicles are also designed for delivering packages on the ground also. Okay, so you will see a lot of autonomous vehicles. We are talking about autonomous cars, autonomous buses, autonomous trucks also. So these are all in form of a drones only. Also there are underwater vehicles are also getting designed for like submarine and everything. Like there is a project which has been assigned to one of the company in Mumbai to do the coastal review of the Mumbai and the Konkan area. Okay, so they have been designing an underwater vehicle which will do all the what is the surveillance of the coastal area. It is known as unmanned aerial vehicle, that is UAV, or remotely piloted vehicle, that is RPV. Entire system is known as unmanned aircraft system, that is UAS, or remotely piloted aircraft system, RPS. So when you say RPV, means it is you're talking about a vehicle, okay, or UAV, we are talking about the vehicle. But when we are talking about the entire system, it is either UAS or it is RPAS. Okay. Yes, Nishan.
I had one thing to say, and I have one question.
Yeah.
Regarding underwater, I think the first was introduced in the last Kumbh Mela. Underwater drones were introduced for the first time in India, maybe.
Okay.
Do you have an idea
I
about
have
that?
no idea. I have no idea about it. But
Yeah, the
Kumbh
Kumbh
Mela
Mela
was
that
not the
happened.
first. There are already some companies who are working on underwater vehicles.
No, no, the first I mean to say the implementation by the
uh,
government.
I mean, it was maybe officially implemented during the Kumbh Mela. Also, drone were used for crowd monitoring. Also, okay,
Yes,
the
yes.
order was given to IG drones. Okay, so they have been using it for that purposes.
So what I came across was drones were used underwater for the safety. Those who are taking a bath
Thick,
to
thick.
yeah dip
Yeah, yeah.
basically.
For
And so
monitoring purposes, they have tried using this. Okay.
yes.
Government of India has awarded these projects to couple of organizations. So that was a use cases for testing in a real type scenarios.
And so regarding the balloons, how they used to maneuver the balloons,
There is no maneuver; it is on its own. That's
but
why they
the
are unsuccessful. That's why they were unsuccessful.
but so the we cannot define the path that this should go in this
It
place.
is the motion of the air. तो
Okay,
फॉर एग्जाम्पल अगर मुझे बलून उड़ाना है और पाकिस्तान पे भेजना है तो आई कैन नॉट डू इट बिकॉज माई एयर इज ऑलवेज नॉर्थ वेस्टर्ली विंड्स तो आई कैन नॉट रियली फ्लाई बलून एंड थिंक दैट कि मेरा बलून पाकिस्तान पे जाए अटैक करेगा नहीं हो सकता आई कैन फ्लाई माई बलून फ्रॉम लेट से बिहार एंड इट कैन गो ऑन बांग्लादेश बट पॉसिबिलिटी अगर वो बांग्लादेश से भी आगे क्रैश करेगा तो शायद त्रिपुरा में जाके क्रैश कर देगा या गुवाहाटी अपना व्हाट इज आसाम में जाके क्रैश कर देगा so there is a risk in that. So here you are not maneuvering it; it is going on its own because of that. So Japan used that advantage because Japan is again on the eastern side and the your what is this? Sorry, on the western side with respect to America. So Japan used to launch the balloons, and the balloons used to reach Pacific Oceans, and then they will cross the Pacific Ocean, and they were think that it will go to Los Angeles or California kind of cities. But Pacific Ocean has its own different way of current of wind motion. So a lot of balloons never reach the ground. They reach the mid of the Pacific Oceans, and they dropped because they were not able to fly endlessly. Okay, only possibility was that one or two balloons have reached the western coast of America, but they were not also been successful in creating any destructions or havoc.
तो पेलोड को रिलीज कैसे करते थे?
There was a fuse mechanism to it at a certain way. So they calculate कि अभी drone मेरा उड़ेगा, so how much distance it will, based on the air flow they used to calculate the distance. कि okay, this many distance it will go further, and then they have a fuse mechanism put it, so that fuse will after certain period time it will automatically trigger. तो वो payload पे release करता था, so it will keep on dropping the bombs, or even if they want to make it lighter also they have a fuse mechanism where it will drop the sandbags also. तो आपका जो balloon है वो lighter हो जाएगा, so it will rise more up in the sky. So that was also built in. But so these are all initially autonomously tried options, but they were not really successful. But it paved a way that we should do something like this autonomous. Okay? There is a video on the YouTube about this. You can see that it will give you a clear about idea about it. Okay, so when we talk about RPAS is part of RPA plus ground station. So S means entire system. Okay, it is a system. So remote pilot aircraft as well as or remote pilot vehicle and plus ground station. So ground station means not only your remote but the ground station which has a laptop kind of thing, a case box, or where you have a control system of your complete flying of your drone is being monitored through the ground station. Then we call it as RSS. Nowadays, even your remote control has a panel built in into it. Okay, earlier there was a LCD panel which was only displaying certain parameters, but nowadays it has been upgraded to a LCD. It's like a tablet, built-in tablet, where you can see the entire drone flying. Even your FPV camera footage is visible on your RC control. Okay, so your RC control is as equivalent to your GCS also nowadays. Okay, so how does drone works? It may be remotely controlled by a human operator. So this is RPAS. Okay, RPAS movement, and this is autonomous. So a lot of time when we use a remote control or GCS, this is autonomous flying of the drone. So fly autonomously with help of onboard computers. It may be remotely controlled by human operator. So when we are saying subcategories, this is RPAS category. Okay, so when the person is holding a remote in his hand and he is flying the drone, then it is called as RPAS category. When it is being flown using the GCS, we call it as autonomous UAS. Okay, you got the understanding what is the subcategory about the drones, and what is the third subcategory? Any idea? थर्ड सब कैटेगरी क्या था? हमने ड्रोन रूल्स में पढ़ा था. रूल नंबर 3. Yes, Priyan.
Was it the model RPS?
Model RPAS. Correct.
Yes.
Model RPAS. So, what is the limitation of model RPAS? Or what is the criteria for model RPAS? How do you define? How do you differentiate between model RPAS and the normal RPAS? Rule number 3 again. So you need to read Drone Rules 2021. Rule number 3 says your model RPAS is limited by weight of 25 kg only. You cannot go beyond 25 kg, and it can be only used for fun, recreational, educational, testing, R&D, that kind of activity. You cannot use model RPAS for production or what we call commercial activities. Okay, so model RPAS is only limited to certain weight, and the last criteria is model RPAS only can be used for VLOS. So the aero modeling जो हम लोग करते हैं वो हमेशा we see that aeroplane is always with your eyes, then only you are able to fly it. Beyond your capability you cannot fly them. Okay, it's not like the commercial airplane you are flying autonomously. Okay, so model aeroplanes you are only flying within your visual range of sight. Okay. So multi-rotor drones, rotors with more than 2 rotors is called always a multi-rotor, further classified based on number of rotors. So there is a 3 motors or 3 rotors is tricopters, 4 is quadcopter, 6 is hexacopter, 8 is octocopter. So quadcopters are mostly popular and widely used variant. So quadcopter is very efficiently, very large applications are being used. You see every drone, I would say almost 60-70% our drones are quadcopters. Hexacopters are being used primarily in when the payload is heavy, higher, or in an agriculture segment. Similarly goes for octocopter also. When you are weight is more and you need to pull up that weight more, then you may add more motors and propellers to it. But minimum small like surveillance drones, monitoring drones, inspection drones, photography drones, you can use quadcopter. Okay. Only by adding more propeller, it may go stability, or it may have a capacity to rise, to pick up the weight more, is with a more number of rotors. Any questions on the rotorcraft or classifications of the rotors? Quadcopter, hexacopter, octocopter. So DJI drones are more or less they are always quadcopters. Okay, DJI has been very effectively designing their drones around quadcopter technologies. Even their agriculture drones they have designed using quadcopter technology only. Okay, some of the other drones in agriculture are being made by hexacopter design. Okay. So what are the pros and cons of multi-rotor drones? The pros are vertical takeoff and landing, hovering capability, operation from a confined space. So that of time we would have seen quadcopter are being flown in such a areas, like industrial inspections you do, windmill inspection you do, or power line towers, telecom towers, or even inside the wings of the wind turbines, or even inside the ships also. Like I gave you example yesterday, there was two students who have joined because they wanted to review the structure of the ships inside, okay, or very confined spaces. There you will use multi-rotor or a quadcopter. But what are the limitations of the quadcopter? Endurance is the first thing. Okay, endurance, limited endurance compared to fixed wing. But even though we say endurance, even flying a drone, a quadcopter for 20 minutes to 30 minutes is a huge time. Okay, you will understand when you are flying the drone. When you actually fly the drone, even you fly for a 5 minutes a drone, it's a big time compared to it. Now, in that 5 minutes, what you can do, that is all up to you. In a 5 minutes, you can just keep fly the drone and keep it hovering, or you can fly the drone and create a one pattern, or you can take off. So depending upon your application, your time will define. Okay, sometimes that time would be less also. Okay, because your multi-rotor can only fly for 10 minutes, 15 minutes, 20 minutes, 30 minutes. Max to max, I have seen drone flying up to 60 minutes, not beyond that. Okay, in a quadcopter scenario. Again, it has a limited speed compared to fixed wing. So it has a limited operations. It can be fly within your range of flying. Cannot perform high altitude long endurance. This is what I said, right? It can fly up to 2000 feet, maybe max to 5000 feet. I mean, bigger quadcopters can fly up to higher altitude, but then again, it is a limitations because your air becomes thinner and thinner. So it is very difficult to rise the drone in thin environment or thin air kind of environment. As you go up and up, you will lose the throttle motion of your drone. So it cannot perform high altitude, long endurance capacity. Okay. So quadcopter anatomy. When you see a quadcopter, this is normally most of the people make this type of a quadcopter, where you will have a frame. Okay, that is an air frame. What we call, these are either plastic made or fiber optics glass is there. Okay, fiberglass is there, and then you have a four motors on four corners. Okay, and then there is a propellers attached to it. Okay, to power these motors, there is some electronic system is there, that is called electronic speed controller. Electronic speed controller is like your normal regulator in your house, okay, which controls the speed. But this is electronic, you are not changing the any button, or there it is electronically controlled. Okay, the speed is controlled electronically. So your flight controller normally gives the signal. The power is given by the battery, but how much power to give it to the motor is controlled by the flight controller. It will give the signal that this much power it needs to give it to the particular battery, particular motor, and it has to be rotate the propeller at that particular speed. So this is being controlled by the flight controller, but that signal is being given by the electronic speed controller. Okay, so it will automatically define how much power to be given to the motor. So your AC is the main component which controls the speed of your motor. Okay, then you have something called as first person video camera, which is FPV, which we need to know where actually drone is you're flying. You can use your FPV goggles to check the motion of your drone. Okay, then you have something as a camera with the gimbal. This is your main payload, which we will use for capturing the footages. Either it could be aerial photography or videography. Then your drone will have a landing stress or a landing gear, what we call it, because that is the important component. As you drone flies in the air, it has to land back also. So when it is to land back, it has to make sure that its frame, its components are safe. So you will have something called as a landing gear or a landing stress, what we call. There are different types of landing gears are there. There are retractable gears. There are hydraulic landing gears are there. There are landing gears in a different designs and shapes also. Okay, then you have a powerhouse, that is a battery pack. So neither normally in quadcopter you will always have a battery pack. Either it could be a lithium ion or it could be a lithium polymer battery. Nowadays most of the people are preferring lithium ion because lithium polymer are tend to get leakage, they are tend to get bulge. Lithium polymer batteries are we are using in our mobile phones. So over the period of usage and over period of cycling of charging, you will see over the period of 6 months to 1 year, your phone battery try to bulge. You need to replace them, right? Whereas lithium ion doesn't have that issues of leakages as well as bulging. So before we move to each component, any questions?
Nothing from me.
No,
Okay. So
all
first
good.
component is motor and propellers. Okay, so propeller basically converts your rotational motion to thrust. So as the propellers are moving, the push which is created downwards, it will pull your drone upward in direction. So that is how your thrust motion happens. So there are two types of propellers again, pusher and propellers. Pullers. Okay, so when you say pusher means it is pushing down or pushing backward. Okay, puller means it is pulling forward. So ideally, it is always like for example, you have a wagon. Okay, whether it is very easy to push the wagon. See, like for example, if you are pulling a car, whether to push the car is easier or pull the car is easier. What is easier?
A
Pushing is easier.
combination of both.
Combination is not good, but either, what is better? Easier.
Push.
Push is always easier because you are applying a pressure in forward direction, right? Pulling is you are pulling it. Pulling maybe it will be little compared to pusher. Pulling is always difficult. Okay, you may require more power to pull. Okay, because you are pushing it against the weight. See, both motion are similar, but you will see the difference when you are doing it. Okay, so you will always feel that pushing is always easier. Okay, so pusher is always preferred to puller. Okay, now pusher is clockwise, puller is counterclockwise. Okay, that means what? Lot of time you will see. Now, if you see the picture of propellers over here, these are two types of propellers. Can you make out the difference? Use your Bernoulli principle over here. Yes, Priyan.
Like the propeller on the left is a brushed propeller. Like it's the kind you would see on a helicopter.
Both propellers are for same type,
Okay.
so there is no difference from that perspective. Both are for use for drones only. But you will see the design. One is of one type and one is of another type. Yes, Vishan or Gautam.
So one side of one propeller is thick and other side is thin.
So if you see this propeller, okay, this is the front edge or the leading edge. Okay, the front part, leading edge, and this back side, this curved shape, what you say, which is tilted downside, is called trailing edge. Okay, so this is your leading edge. when you actually see the propeller also, the leading edge will be thicker. Okay, it will be thick, whereas your trailing edge will be thinner. Okay, sharp edges will be there. So now this is your leading edge and this is your trailing edge. So this propeller is called as counterclockwise propeller because this propeller will move in this direction. You are seeing the motion of my mouse or cursor. This is how it will be moved. Whereas if you see this propeller, the black tip wala, okay, there are two different tips, silver tip and black tip. Okay, this is how also how you can differentiate visually also. Okay, the color wise, this is just to make an identification. But if you see this is your leading edge, whereas this is your trailing edge. So this propeller will move in this direction. What is this direction? Clockwise. Okay, so you have two types of propellers on your drone. One is counterclockwise and another is clockwise. Okay, so both are in two different directions. Same principle was used by Wright brothers when they designed their first aeroplane. If you have seen the video on YouTube, the two propellers were there. Both propellers were moving in a opposite directions. One was moving in a counterclockwise, other was moving in a clockwise direction. Initially, when they designed aeroplane, they have used both same direction. इससे क्या हो रहा था? वो जब एरोप्लेन उनका फ्लाई हो रहा था, when the aeroplane was flying, the aeroplane was actually also doing yawing. It was yawing. तो वो उसका lateral axis जो था, vertical axis था, उस axis पे even their aeroplane was moving. So they understood why this was happening because both propellers were moving in the one direction. Same is applicable to the helicopter also. अगर helicopter को tail rotor नहीं होगा तो क्या होगा? Your helicopter is wings are your propeller is moving one direction. Your the helicopter will move in opposite direction. To stop that motion, there is a tail rotor on it. Okay, understood the principle of the propellers and the wings. So you, when you see these things practically, you will see them more and understand more effectively. You have to visualize them, okay, or you can see those videos on YouTube also. So propeller dynamics can be modeled by Bernoulli principles. So the shape of the propeller is used using Bernoulli principles, but the motion, the convert rotational motion to the thrust is nothing but Newton's third law. So your propeller is actually using Bernoulli principles and Newton's third law for drones. Okay. Now, motor are used to rotate the propellers. You can have brushless DC motors which are highly efficient and long lasting. Before brushless DC motor, what was the kind of motor we used to use, or even we use nowadays also? But what was before brushless DC motor was invented? What was the motor we were used to use? What can you know the difference between brushless and normal DC motor?
We would have carbon fiber brushes or something. Carbon brushes.
Carbon brushes were there. Very right. So earlier the motors or even normal your pumps, okay, or even your mixer in your house, okay, or your blender in your house, whatever your vacuum pump, all they uses DC motors. Even your fan, the fan which is rotating on your head, that is also using DC motor. So what is having a DC motor? In DC motor there is a magnet, a fixed magnet, and then you have an armature. Okay, you have an armature in between. So the armature needs to be connected to the power. Now to give a power, since the armature is rotating, now your armature is rotating. So you cannot connect a wire, right? Because if you connect a wire to it, what will happen? As the armature moves, your wire will also move, right? So to avoid that, what you used to do, a spring-loaded carbon brushes were used. So it was actually touching the armature. Okay, so it was touching the armature as it was moving, it was keeping a contact. So you will see a lot of times the spark would happen in the motors also. Okay, because of that, not to happen a spark, that's why they were using carbon contacts. Okay, but eventually the carbon will friction, and because of the friction and all that, they will run. So every 6 months or 1 year, you have to change your carbon brushes. And then because of the carbon, there is a friction happening, touching. The efficiency of the motor was not good, and that's how the scientists or the innovators designed a different type of motor called brushless. So they thought, why don't we avoid using contacts? So what they did, they made a fixed armature. They made the fixed armature. So fixed armature, your armature is fixed, it is not moving. You can connect the wire to it, so there is no friction happening. Now instead of fixed magnet, magnet is moving now. Okay, so you are changing the polarity of your coils. There are multiple coils. There are 36 coils in DC brushless DC motor. Depending upon how you have designed your motor, so there will be 36 coils and 36 magnets around it. Okay, so there will be a polarity. So as you change the voltage of each coil, the magnet will shift. Okay, so as you keep on changing the voltage and the orientation of the coils, the magnet will move in a direction. Okay, so it will create that torque motion. Okay, that's how your brushless motor or a brushless DC motor works. So the key parameter to focus on the motor is motor speed, the thrust value, compatible AC and compatible battery. So when you see a motor, first whenever you decide, so first thing when you design your drone, you have to think about a motor. The motor will be given a speed and a thrust value. I will make it very simpler for you to understand. Like I go to buy a thrust, I want to design a drone. So I will see, okay, what is the motor available in the market. So I will see the values, motor speed and the thrust value. Okay, thrust value is nothing but how much weight it can pick up at a 100% thrust. Okay, so at 100% thrust, it can pick up like one motor can pick up a 10 kg weight. So I am designing a quadcopter. I will use four motors. So one motor is capable of picking 10 kg of weight. So four motor will pick up how much weight? If I combine all the four motors,
40.
40, right? So your drone is capable of picking 40 kg of weight. But I will not design my drone or I will not certify my drone to say that it is capable of picking 40 kg weight. You always, when we design, we always divide by 2. So I will say my drone is capable of 20 kg. Okay, so normally, like for example, when I am saying my drone is capable of 24.9, so roughly say 25 kg of weight it can carry. So that drone is not designed for 25 kg. That drone is designed for 50 kg. Okay, that drone is capable of 50 kg of weight it can pick up, but you can use only half of the thrust. You should always use half of the thrust for efficiency flying. आप क्या, you will never drive your car at 240 kilometers per speed, right? What is your average speed? 100 to 120. But your car is designed to drive at 240, but that is only in 100% efficiency or 100% ideal conditions. You cannot drive your car to 240 speed, right? Though it has been designed, you will always drive your car max to like 100, 120, 140, max to max 150 के ऊपर आप जाओगे, उसके ऊपर नहीं जाओगे. उसके ऊपर जाओगे तो क्या होता है? What happens when you are driving a car at that speed? It will strike,
Wobbling.
wobbling हो जाएगा या unstable होना चालू हो जाएगा, right? So you will feel that. So you never fly, but your car has been designed for that speed, but you will never. So similarly, your drone has been designed for 50 kg weight, but your drone is certified to take only weight up to 50% of it maximum capacity. So that is your 25 kg. Okay, that is how you certify your drone. So for example, I give you a motor which has a capacity of between 6 kg of weight. So what will be your total capacity of your drone? Maximum capacity?
Sorry, could you repeat that again?
I give you a motor of capacity of 6 kg picking of weight. So what will be your quadcopter maximum thrust and what will be the payload capacity? Yes, Nishan.
Double of that. 12.
6 kg है एक मोटर का, तो 6 into 4,
अच्छा,
24.
24. So 48
24 उसका कैपेसिटी है, but
48.
divide by 2. So 12
Divide by
will be the actual weight of that drone, including payload. You cannot exceed beyond 12. You should never exceed beyond 12 because there is where we are using 50% of efficiency. Okay, ज़्यादा weight होगा तो क्या होगा? Suppose instead of 12 I use 18 kg. वो करेगा because it has that power. The motor has capacity to it, but it will draw more power from the battery because your motor has to rotate at 75% of throttle, not at 50% of throttle. Okay, so continuous आपके motors बहुत high speed पे घूमते रहेंगे. More the motors are rotating, the more power it is drawing from the battery. What will happen because of that? Your endurance capacity of your battery will reduce. So that's why we always design drone for 50% of efficiency. So you get more and 50% or less, 50% or less. So that अगर आप उसमें मतलब वेट ही नहीं डालोगे, सपोज 10 kg का ही वेट रखता हूँ मैं, but my drone is capable of 40% 40 kg of weight. What I will happen by putting a battery? It will give you more flight time because weight is less. It doesn't require that much motors to rotate. So less power is being consumed. So I will get more flight time. Got it?
Will it contribute to safety also in case one of the propellers fail or something?
No,
You still
no, no. Quadcopters are never safe. Even single motor fail, your quadcopter will fall down. Hexacopter will sustain some extent because there are 6 propellers. So it will try to, it will be unstable, but you will still have some time to safely land it. Some time, not much time, but some time to safely land it. So multi-rotor drones cannot be managed if there is a motor failure. That's why there people are talking about setting up some mechanism where like a parachute. Okay, but then you need to have your drone also up in the air at least considerable height so that it gets time to launch the parachute and time to land it safely.
So a single propeller failure, it will go out of control, correct?
Out of control. Yes.
Okay.
So understand, as you change the speed of 2 propellers also your drone gets killed, right? That is how your forward and backward motions are happening. So imagine one motor completely stopping. So 3 motors are moving. Again, they are all balanced. If you see the design, I have not come to that topic. Your motors and the motion of your propellers are there in opposite direction. Like opposite direction motors are moving in the same direction. Like your first motor and your fourth motor. Okay, like you say, if you say 1, 2, 3, and 4, so your first and your third motor. Okay, diagonally opposite motors are moving in the same directions. Diagonally opposite motors are moving in the same directions, or diagonally opposite propellers are of same type. Okay, so I am not talking about this because I wanted to show them you practically. Physically, I want to show it because that is the time when you will understand them more effectively. Okay, in some pictures I will show you, but that is more effective when I show them you practically. Yes, yes, Nishan.
No, this is by mistake. Sorry.
Okay. So now you have propellers and motors, and now motor needs to be controlled. So you use electronic speed controller or what we called as ESC, used to vary the motor speed with precision. Okay, so the flight controller, whatever the signal is being given, that signal will be get converted by the ESC, and then accordingly the power will be given to the motor with very precise way. Okay, whatever the RPM is required, only that RPM. So as you move your joysticks left or right, so smoothly वो left or right motion होगा या forward upward motion होगा. Whatever motion you give through the joystick, the flight controller will sense that session, that signal. Flight controller will give it to ESC, and then ESC will convert and give that power, required power, to that motor. Either it is less, more, or whatever it is required. Okay. So if you see the motor, okay, for example, motor, there will be a rating given by on it. Okay, so there will be like let's say motor is been designed for 30 amperes or 25 amperes. So on ESC, you will be seeing something like ampere ratings. So if your motor is designed for let's say 25 amperes, so you have to use ESC of higher capacity or higher value. तो अगर आपका मोटर 25 का है तो use higher value, that is like 30 amperes or 35 amperes का ESC. Because what is happening, as motor is rotating, motor is drawing the current from ESC. अगर आपने 20 amperes का यूज किया या 25 amperes का ही यूज किया तो क्या होगा, आपका ESC will become hot, गर्म हो जाएगा, जल जाएगा. So you will always use ESC of higher capacity. So So that is what I'm saying. If I used a motor which is using 10 kg ka weight and it has been given the value of ampere, like let's say 25 amperes. So I will use AC of either 30 amperes or 35 amperes, higher value, certain higher value. I can use 50 amperes also, but there is no use of 50 amperes because it will be wastage of 50 ampere AC will be costing you more compared to 30 amperes or 35 amperes. So you will use nearby. अगर आपका मोटर 25 एम्पियर्स का है तो यूज 30 और 35. डोंट गो फॉर 50 or 80. यू कैन यूज देम. ओके, आपको एसी को कुछ नहीं होगा, बट देन इट विल बी अननेसेसरी increase the cost of your drone. Okay, so you will efficiently use the nearby value of AC. अगर 20 amperes का मोटर है तो I can use 25 ampere of AC or 30 ampere of AC. Okay, that way how you will design your drone. So compatible AC is important. Based on the motor and the AC, you will use battery. Again, battery is weight as well as power. So again, you need to balance out. So when you are designing a quadcopter, lot of things you need to come into the picture. One is the structure, then the capacity. What is the purpose of your quadcopter? What purpose you are designing your quadcopter? What is the use case of the quadcopter? What is the total weight it could have to weigh? All that will come into the factor, and based on those parameters, you will design your drone. Okay, based on that, you will keep in mind what kind of motor. So first, once you define your motor, motor will give you specification that there will be what compatible battery would be there, what compatible AC would be there, what compatible propellers are also there. Nowadays even propellers are designed for particular motors. तो मोटर का जो आरपीएम है उसको वो आरपीएम को स्टैंड करने के लिए यू नीड अ propellers also to be designed. Okay, whether you need to use a plastic motor, plastic propellers, or you have to use carbon propellers, that will be also defined. So there will be a specification sheet along with the motor which defines what propellers I can use, what AC I can use, and what battery can I use. So once you are zero down on a motor based on your weight capacity requirement, you can define other parameters too. Okay, so can control the direction of rotation of a motor either CCW or CW. So using these three lines, three wires. Okay, if your motor is moving in a counterclockwise, by just changing or swapping two wires, your direction can also be changed. But this is not followed in a enterprise drones. It is not ideally suitable. So your motors are being even for higher end drones like enterprise drones, aggregate drones. Your motors are also designed for a particular directions only. Okay, you can't replace them. You can do that for a timing, but that will actually overkill your motor. Okay, so motors are designed again for clockwise as well as counterclockwise also. So in a higher end drones, you are not advised to swap the motors. Like अगर आपके पास clockwise नहीं है तो मैं counter clockwise use कर सकता हूँ, and by changing the AC cables. Okay, that is possible, but it is not advisable in enterprise drones. Smaller drones, fun drones, toy drones where we use, there we can do it because they are very low quality motors. Okay, so there is no motor which has been designed for toy drones which is specific for direction. Okay, again these ESCs act as a dynamic brakes battery elementing circuit for powering the flight controllers or receivers. You can see this small wire is also there. This wire basically takes the signal from the flight controller. Okay, so powering the flight controller, even you can power it through the these wires also to the flight controller also. Now, after AC controller is a very passive device. When it gets the signal, then only it will convert and give the power to the motor. But then there needs to be intelligence, right? Like for example, you are doing autonomous flying, or even you are when you are flying manually, you are giving some controls. The way you give controls to your drone, it will fly. So the flight controller is actually a brain of US. It helps in a flight stabilization or navigation and fail-safe redundancy. So all that configuration, whatever we do with respect to the safety, security, and smooth flying of your drone is done by using flight controller. Okay, so most common flight controllers are developers are Ardu Pilot. Now Ardu Pilot is the most mostly use flight controller. So I would say almost 80% of drones uses R2 pilots, or people have derived new flight controllers from the technology used by R2 pilot. So you see DJI or M-Lite, NASA M, V2, Air 3, or even other customized flight controllers which are available in market. They all are using the concept of R2 pilot only. Okay, the famous flight controller is called as Pixhawk. You can see here Pixhawk, and there are a lot of variants of available of Pixhawk. This is a very basic flight controller called basic Pixhawk, and higher versions are like Pixhawk Orange Cube, White Cube, Blue Cube. Based on the color and the configuration, there are different types of flight controller available. Then, along with the flight controller, you use some additional sensors or controllers also. So there could be a GPS, there could be a uh, control units also like IMU is an also. So we'll see that in subsequent slides. So then there we talk about the airframe. So based once you design your motor, you design your propeller. Your propeller may be 12-inch, 18-inch, 10-inch, 24-inch, the diameter of your propeller. Based on your diameter of your propeller, you will design the airframe, right? Your airframe which consists of housing the enclosing electronics, motors, boom arms, and platforms. The different configuration of quadcopter could be H-shape, X-shape, plus shape or H-shape hybrid also. So you can see here there are different shapes are there. So depending upon your dimension of your propeller and the orientation, how you balance it. So basically you need to balance your drone. So when it is in air, your CG should be always at the center at any given point in time. So you will design your positioning of your motor, because you are not only the motor and it is not only about flying, but the purpose for which the drone is being made. Okay, agriculture drone है तो आपका tank कहाँ पे रहेगा, आपके batteries कहाँ पे होगी, all that, and the motion of them, because every time you are flying agriculture drone, your weight is getting reduced because you are spraying, right? So initially it may be a 24 kg, but as it is functioning its purpose, it is putting the fertilizer on the crops. It weight will start get reducing. So every scenario, right from highest weight, that is 24 kg, till it comes to let's say 14 kg, within that range the drone has to be stable. So without fertilizer tank being loaded, and with the fertilizer tank 100% loaded, the drone has to perform at the same level or the same way. Okay, so that is how you design your airframe, okay, based on your requirement. Now, once you have designed the airframe, you will put a power pack or a power plant, what we call a battery pack. In case of your electronic drone, you will always use a power plant which is litho or lithium ion, widely used, because high energy density compared to conventional batteries. Normally, whatever the torch batteries what we use, right, AAA or AA cells, they are not very high power. Their ratio or energy density is very less. They can only power small LEDs or small bulbs and all that things, but they cannot actually make drones, because drone will draw a lot of current. Like we talked about something like 24 amperes, 25 amperes of current. Okay, so it requires a lot of power, energy. So that's why we use always lithium polymer or lithium ion batteries. So if you see the batteries, there are two things which you need to see. One is the capacity. So, like for example, you see 5000 mAh. You might have seen in your mobile, like earlier, our mobile was powered by 1000 mAh. Then we got a mobile with 2000 mAh. Nowadays, we are having a mobile which are powering of 5000 to 6000 mAh. Even there are mobiles which are powered now by 10,000 mAh also. So more mAh capacity means more power, more lifetime for your mobile. Same thing we will go for drone also. 5000 mAh will give you 10 minutes of your endurance capacity. If I use 10,000 mAh, so 10 minutes ki jagah pe it will try to give me 20 minutes. But since you are changing from 5000 to 10,000, what is happening? You are doubling the size of the battery. Means 5000 mAh battery is weighing, let's say, 2 kg of weight. 10,000 mAh will what? 2 kg plus 2 kg, 4 kg. Automatic, your weight is getting increased on your drone. So not necessary by moving from 5,000 to 10,000, you will get double the power. There will be some power will be get reduced because of your weight getting increased. So instead of getting 20 minutes, you may get only 15 to 18 minutes of flight time. Okay, understood? Because of the weight, what is how it is impacting, because you can't increase the battery. That is what is the current limiting factor when we are adding power to our quadcopters or hexacopters. The more power I to try to give it, I am not getting 100% efficiently flight time. I may have to compromise because of the weight getting added to my drone. Okay, and second is the cells. Okay, 50 cells, 60 cells, whatever the C value is there. C value is the discharge rating, how much it will. So normally by 5000 mAh and 50 cells, my drone will have, let's say, endurance of 10 minutes. The higher the cell value, the more discharge rating would be there. Okay, so but don't get confused by the C rating or anything. You always concentrate on the MAH value. Okay, the more MAH value, the more power will you get. But again, adding more power, your drone battery will become more bigger or heavier. Okay, so as of now, I am having a drone which is using 21,000 mAh battery. I can easily replace that 21,000 by 30,000 mAh. But 21,000 mAh battery, weight of 21,000 mAh battery is 2.5 kg. So like that, I am using two 21,000 mAh batteries. So my weight of my battery is almost 5 kg. अगर मैं वहां पे replace that by 30,000 mAh battery, the battery weight is from 2.5 kg, it is going to 3.5 kg. So automatically two batteries of 30,000 mAh will go from 5 kg to 7 kg, यानी 2 kg weight बढ़ रहा है. So my drone will change weight from 24.9 to 27. No longer my drone will be in a class of small. My drone will be of class of medium. So I have to get my drone recertified. Okay, so same thing is applicable when my IoTech company, the original OEM manufacturer, they designed a drone. They have not designed a drone for medium class. They have just replaced the batteries from 21,000 mAh to 31,000 mAh, 30,000 mAh. So automatic weight बढ़ गया. They just have to recertify that drone. So automatically they got a drone also in medium class certified as a type certified. बाकी कुछ change नहीं हुआ है. थोड़ा सा dimension changes किया है for efficiency purpose. That's it. But अगर आप small drone भी देखोगे और medium drone देखोगे, both are same type. Nothing has changed. Only because of the battery weight, the weight has changed from 25 kg to 27 kg. Since it is 27 kg, उसका class range change हो गया. It becomes from 25 kg to 150 kg का range में आ गया. So that is a medium class. Okay, but if you fly both drones, the way you fly, the feel of the flying is almost same. No change in it. So you really don't require to initially get certified on medium or fly medium class drones. You are already flying of that capacity or of that class. Okay. Quadcopter, again you will be having a gimbal, like if you are using it for cinematography or aerial surveillance or monitoring purposes, you will always have a camera with gimbal. So gimbal basically is used for to mount the payload and helps in stabilization as well as pan and tilt mode control. So earlier there was no gimbal on the drones. Okay, it was directly a fixed camera was there. So when fixed camera is there on the drone, what happens? If I want to take a photograph with an angle, I have to move my drone. Right, I have to give a power to the drone. So there I am utilizing the battery of a drone. In case of gimbal, what happens? My drone can hover at a stable. So my drone will be at a very stable. Battery consumption will be very low. So I am only using simple motors in the gimbal. So only gimbal is changing the angle of the camera, and I can take effectively the images. Yes, Gautam.
So does this gimbal use the gyro principle, or only with gravity it keeps it stable?
No, gyro is there. Gyro is there.
Okay.
That's how it's stabilized. Okay, so that's why
Okay.
though your drone is motion, it will help you to stabilize. So gyro is there which controls the motion. So it could be 2-axis gyro or it could be a 3-axis gyro. So that's why we call it 3-axis gimbal or 2-axis gimbals.
Okay, but there are gravity-based also gimbals.
There are gravity based, but then they're not so efficient. They will not
Okay.
give you that stabilization what gyro is giving.
Okay. Thank you.
Then we have a landing thrust. These are the legs that drone rests on when
Sir,
it is.
I have one question, sir.
Yeah, yeah.
So how do you control the gimbal from remote?
There is a separate gimbal stick is there. Okay, or in your case, like cinematographer people who are using like DJI Inspire. DJI Inspire has two remotes. One remote is given to the pilot who flies the drone, and there is another remote which has I mean, both are remote are same only, but only two remotes are being used because one is controlling the flight motion of the drone, and one guy is controlling the motion of your camera. You know, tilt, pan and tilt motion, the way you want to shoot. So that is, so there are two people who are actually controlling the drone and the camera. So one person is controlling the drone, one person is controlling the camera. The same can be done by one single person also, but then you are performing two actions or two activities at the same time, which will be very difficult at that point in time. Okay, if you are taking a very dramatic shot or you are recording some session, which is like chasing a car or chasing, like horse riding, those kind of shots which have been taken, where you need to fly the drone as well as you need to keep your subject into the center also. To control that, nowadays you have something called a camera which has a live tracking also. Okay, so they are AI based cameras or smart based cameras, what we call. So we'll say this in subsequent slides also. Okay. So landing thrust, these are the legs that drone rests on when it is landing or grounded. Comes in a different shapes and sizes as the design of UAV. Can be folded with the help of servo mechanism, resulting in better field of view. So now I give an example: DJI Inspire drone, which has a landing gear, which actually when they go up, it goes up. Okay, they get refracted upward, so that your camera has a complete 360-degree view. Okay, so the legs doesn't come in between, so you can move your camera completely 360 degrees. Yes, Nishan.
What is servo mechanism?
Servo means you can precisely control. This is another type of motor where whatever angle, like you want to move your motor only from, let's say, from a 0 degree, I want to just move for 20, 10 degree, 20. Very precise movements are required. So in robotics arms, robotic motions, you use servo motors where you can precisely control your movement. Like you have seen those arms in in a robotic arm, like it moves only specific directions like this. So these are controlled by servo motor. So you give a specific signal, it will move. Whereas this normal DC motor is what you give just power. So वो rotate करेगा. It will complete its rotation. In servo motor, it will not rotate completely. It will move only a specific degree. Okay, those are your servo motors or servo mechanism. Okay, I had it in my table, but I don't know where. I think my daughter it kept it somewhere. I have a small servo motor. I will show it in the lab when we go for a practical. Okay. Any further question? Nishan, you have a question?
No, no, no. I think this hand is. Will have to do it manually.
Okay. So another is radio transmitter and receiver. We talked about the radio transmitter during the control motions, pitch, roll, pitch, throttle, yaw. So radio controller transmit the input given by the pilot to the receiver via 2.5 gigahertz. Yesterday I showed you about the spectrum, RT spectrum. Okay, so very high frequency and ultra high frequencies. These are in this band. So you have 2.4 gigahertz band which is being used by your remote control to connect to the drone. So there is a remote control and there is a receiver. Okay, this small device is a receiver which receives the signal from your remote control, and then this is connected to your flight controller. Okay, so the signal from the receiver is given to the flight controller, and then flight controller will take the decision based on whatever actions you have performed on the your remote controller. Similarly, your video transmission, there are FPV cameras attached to your drones that is using frequency 5.8 gigahertz. Okay, because it is provides a noise-free and best quality video signal. Okay, so your FPV is using 5.8 gigahertz signal, whereas your remote controller and the receiver is using 2.4 gigahertz. Now, see, this frequency is an open frequency. If I bring a similar type of a controller in the same field and I try to use it, it will control my drone. right? You have seen in a toy drone lot of time, if अगर मेरा remote control खराब हो गया तो दूसरा toy का मैं remote control use करूँ तो वो भी उस पे चल जाता है, right? और even in TV also, like lot of time हमारा remote control खराब हो जाता है तो हम क्या करते हैं, हम TV का remote control लेके आते हैं, then we just use it, वो use होता है because it's a open ended thing. But in drone, okay, in a type certified drone especially, or the drones, they are binded. Okay, so this remote is binded with this receiver. तो अगर आप दूसरा रिसीवर लेके आते हो, you can get additional receiver. So this remote can be used for multiple receivers also. So if you want to give a signal to a particular receiver, your receiver and the transmitter has to be binded. Okay, so this remote can be binded to more number of receivers also. Okay, so I don't need every time use multiple remote controllers and all the things. I can only buy separate receivers over here. Okay, but they need to be binded. अगर bind नहीं हुआ तो क्या होगा? I can bring this type of a remote and I can hijack your controls. Okay, which is not accepted in drone flying. That's why in type certified drones, the DGC has made it very mandatory. Your drone needs to be binded to the specific receiver only. That cannot be changed. So that is how you are safeguarding your operations. Okay, so we'll see that in your emergency situations also, where your hostile takeover of your drone can happen. अगर मैं अपना GCS लेके आऊँ या मैं मेरा remote control लेके आऊँ, I can take a control of your drone. It should not happen because you are only controlling over open frequency. Okay, that is 2.4 gigahertz पे आप frequency पे communicate कर रहे हो, but that frequency cannot take signal because it is following something called as binding technology. Okay, like हम लोग Bluetooth करते हैं, pairing करते हैं, अगर बिना पासवर्ड के pairing करेंगे तो क्या होगा? Anybody can take a control of my mobile, or anybody can access my Bluetooth, right? Or anybody can use my Wi-Fi signal also if I do not have password. If I put a password mechanism, then it is I am limiting who should access, who has access, or who can control my Wi-Fi, or who can use my Wi-Fi, or who can use my Bluetooth service. Similarly, in a remote control, when you put a binding, you are controlling or you are limiting the controls. Yes, Priyank.
Can drones be connected to laptops and other control units? If
Yes,
like,
yes.
is
So
it
you
possible?
can see here, na, this is a laptop only. What you see on the right side device, this is a laptop only.
Right.
Actually, it is a laptop only.
Hmm.
Okay,
No,
but it
I
is,
meant more like if I have a drone.
if you have a
Uh,
laptop, you can connect it, but then you need
okay.
a telemetry device for that.
Right.
There
Right.
are there are devices which you need to connect to your USB, and then you have another side which is controlled to the drone. So you
Right.
will have again a transmitter and receiver. So
Hmm.
using your laptop, you can actually control. That is what I was talking when I was giving an example about mission control software. If you can download mission control software on your laptop. You can use your telemetry devices, and you can control your drone using laptop also. You can fly your drone on your own.
Right.
Okay, so telemetry, that is what is the topic. Air end is connected to UAV. The ground is connected to the GCS control. So GCS control can be a laptop also, or there are dedicated GCS control. The dedicated GCS control are nothing but they are dedicated for, because these are devices which are to be used in a very hostile conditions. Like if I am using it in a desert locations or a very mission control, so I will have this case, okay, where I can just open it and start it and use it. Okay, so needs to be protected because it should not be taken over. So it will have a lock and key mechanism. It's not like your normal laptop, you just open it and you start using it. So this will also have some fingerprint mechanism to open it also. Okay, so this will, that way these cases have been designed. Provides crucial telemetry data. Like your normal laptop, if you install the mission control software, you will get all this information like altitude, distance, speed, wind, and other parameters like even temperatures, where it is flying. Even the video footage will be available. Even your GCS map will be available on your screen. So all these things will be available. Now this controller, what you see on the left side, this is a basic remote controller. Okay, you see there is a only LCD, so it will only display text. But the controller what we are using for real flying, the enterprise drone what we are using, they are as good as their GCS, handheld GCS. So instead of LCD, this LCD or LEDs, okay, you will have a display, okay, which is like your mobile or your tablet. So you can see whatever you are seeing on this panel over here on the right side, all the things is available on your handheld remote control. Okay, so we are using H16 remote control, okay, which is a very high quality remote control. It costs almost 1.5 lakhs, okay, or 1.25, 1,25,000, around that range that controller is. Whereas this remote controller, you get it in 5,000 rupees to 12,000 rupees, okay, max to max 20,000 rupees, not more than that. Okay, these remote controllers are very basic remote control. These are used basically for playing the games, simulators, or flying your aero models. Okay, aero modeling aeroplanes for that purpose only. Their range is also limited. Like it could be probably max by 5 kilometer range. Whereas my remote control might have a range of 10 kilometers to 20 kilometers range. Also. So they are very high end remote controls. Okay. Then quadcopter, you will always see there will be indicators, the strobe lights, what we call necessary to maintain the orientation. So when your drone is on the ground, you know what is the front, back. You should able to identify. So this will be part of your practical to identify your drone front side, back side, left side, right side. Okay, how to identify when you look at a quadcopter, because quadcopter is similar in all the directions. So whichever direction you see, your drone will be similar, but you still need to see and identify your front side, back side. And when you are flying, when you are in front of the drone, it is in front of you, but when it is away from you, when it is in air, it is far, let's say 500 meters far, then it is very difficult to find the direction. So to understand the direction, sometimes the arms are being color coded. You will have a backside red color, front side white color, or whatever way you want to understand. Some will put some reflective materials or some reflective tapes they will put on the drones. Or currently, all most of the drones are now coming with the LEDs or strobe lights. Okay, so DGCA has made it mandatory now. All the drones should have strobe lights. So this will come. This now not really mandatory, but it is a part of a type certification. Okay, but this will become mandatory when BVLS conditions will come, because you will be flying your drone in night time also. Okay, so that point in time, in night when you are flying the drone, you should know which is the orientation of your drone, which is front, which is back. So you will have a different color LEDs on or the strobe lights on your drones. Okay, so necessary to maintain the orientation. So जब आप fly कर रहे हो, अगर आपका direction of a drone is in other direction and I say roll right, your roll right will be wrong, right? Roll right की जगह पे क्या होएगा? Roll left हो जाएगा. Because if you do not know, like अगर आप drone उड़ा, when you are flying the drone, your drone is in forward direction और आपने उसको 360 डिग्री पूरा yaw कर दिया और तभी मैंने बोला roll right, तो roll right होगा तो क्या होगा? आप roll left दे दोगे. Okay, so you need to, when you are flying the drone, with respect to the drone heading or the forward motion, okay, you need to see it. So forward motion के हिसाब से और forward motion, according to the forward motion, you have to think about your other motions, left and right, front and back. अगर आपका forward motion आपको face कर रहा है and you say pitch forward, what will happen? It will not happen pitch forward. The drone will come towards you. It will not happen pitch forward. Okay, so you need to be careful. So you need to know the indication of your drone. Okay, then you have ADSB. This is what is yet to be implemented. So this is a device. The Ping 2020 is a similar type of devices are available in market, which is automatic dependent surveillance broadcast. Okay, your commercial aeroplanes are fitted with these ADSB devices. That's why they are broadcasting its position and information about itself. So aircraft determines its position via satellite navigation and periodically broadcasts its, enabling it to be tracked. That's why the radars or ATC are able to track your aeroplanes. Right now, ATC are unable to track your drones because this device is not fitted in your drone. But in near future, TGC will make this mandatory. Okay, the moment it has its own UTM platform and it releases BVLS rules, they will make sure that ADSB is compulsory in the drone. Okay, and then it will completely change the drone industry, because this will be more effectively when you are flying drone within the city or intercity also. Okay, so any questions so far on ADSB, strobe lights, radio transmitter, receiver, telemetry? No? Let's move ahead quickly. So microcontroller is a brain of a flight controller. So when you see flight controller, is a big package device. So the flight controller might have a microcontroller. There could be a lot of other circuitry also within that flight controller. So microcontroller is a brain of a flight controller. Like it's like a CPU. Like हमारा पास मशीन रहता है, सिस्टम रहता है, कंप्यूटर रहता है, उसमें जो सीपीयू रहता है वो ब्रेन रहता है, दैट्स अ माइक्रो कंट्रोलर. Collects the measurement from all the sensors, tells the motor what to do based on the both sensor and the user inputs, often connected to the ground station through the radio or connected to a pilot through a control link. That is a telemetry devices. So there are, along with the microcontroller, there will be other devices, other sensors are there. Like you have a altitude and heading reference system. So this is a small circuit which actually gives the orientation of your drone. It will know when it is happening yaw, when it is doing roll, when it is giving pitch. So it will tell where aircraft is moving. So अगर आप pitch कर रहे हो, so that signal will be given or that sense that information will be fed to the microcontroller. So it knows कि pitch forward करने से वो कितना pitch forward हुआ है, कितना pitch back हुआ है. So all that information is given by altitude and heading reference system. Okay, so from A position to B position, जो भी movements होता है, it will be fed by using this circuitry. Okay, not necessary this will be a separate circuits. You can design by having a different modules by this also, or you get a complete circuit like whatever I gave you example about Pixhawk Orange or Pixhawk Cube. You know, these are the flight controller which will have all this circuit integrated into one single board. Okay, so they like that. There are other circuitries also like IMU. Okay, inertial measurement unit is an electronic device that measures and reports a body specific force, angular rate, magnetic field surrounding the body, incorporates accelerometers, gyroscopes, compass, magnetometer. So these are all different modules are there of electronics which does, you know, like accelerometer will measure the speed, gyroscope will measure the orientation or keep the orientation, compass will show the direction north west east west. Okay, magnetometer will tell the magnetic field around the drone. Okay, so as I was flying, my pilot was flying the drones near the power line towers. They went very close to the power line tower near to the wires. So wires were giving inductions, and two of my drones got faulty because of they going very close because they were not magnetically shielded. So we checked with the DJI, and DJI told that the earlier version of Mavic drones were not uh, magnetically shielded. So you have to keep them at least 5 meters away from the towers. So you have to fly 5 meters away from the tower. The more you closer you, the magnetic effect will affect the board and it will damage the board. So I have two drones which got damaged because of this misunderstanding of this, or we were not aware of this. Okay. So now whenever we want to fly the drone, we will always see the specification of that particular drone and then see whether those drones are capable of flying near the power line towers or even whatever area I am flying. Yes, Nishant.
I would like to share one experience of mine.
Tell me.
So we were shooting for Gujarat Tourism,
Okay.
and we were supposed to shoot for the episode of the Statue of Unity and Narmada River.
Mm-hmm.
So we went to the authorities. We took the permission, but the
Mm-hmm.
permission was given to us somewhere around more than 2 kilometers away from the statue, because the statue was just one day before the inaugural. We went on
Okay.
30th of October, and 31st I think was the inauguration.
Okay.
So we were given that field. We were told that you should go to this particular village and from there you can shoot. So while shooting, by mistake we crossed the line by mistake. So we did not get the precise जो नाप होता है 2 kilometers का, and they had kept jammers over there. So our drone signal was lost, and we had to go all the way finding it into the forest. It just landed somewhere in the
Correct.
forest.
Correct. So they have demarcated the area. See, there is a other. This is a counter way of limiting your drone in that area. So you put a jammer, so you are actually blocking your 2.4 gigahertz signal. The moment you enter, it will cancel the signal. Okay, that's the way you are. So you are actually pumping those frequency there where it will cancel the signal or it will create a jargon in the signal, and that's how your drone will not able to understand the inputs, and that's why your drone will lose its control. Okay, over the period of time उसका बैटरी खत्म हुआ रहेगा और पता नहीं रहेगा, स्ट्रे हुआ रहेगा या फिर कहीं जाके ठोक दिया रहेगा, all that things would happen, or it would have been crash landed on the power line tower or a tree or a building, anything could have happened. Okay, so that's still there. So you need to, when you are planning this, when you are flying the drone, you should have created a outer boundary, like how you have a geofencing, you would have defined an obstacle. Your Statue of Unity was like an obstacle. So the moment you try to cross that 2 kilometer ka range, before it like 5 meter एक sub boundary होता है. Okay, so before 2 kilometer there will be 5 meter का obstacle threshold setup होगा. The moment you are nearing and you are near to the red and you are in a 5 meter range, it will give you a warning that you are reaching the obstacle boundary. तो आप immediately आपका pilot would have retracted back, वो pitch forward को pitch back कर देता था. Okay, or that thing, or you would have created a plan to fly the drone. Since you are doing manually, that's why this problem has happened. So a lot of time now projects are given to the people who are able to fly drone autonomously. That means you are creating a plan. They don't want people to fly manually. Okay, they want people to fly drone using plan, and then that plan they need to show, explain, and then the action is being taken. Okay,
So
that is
will
how.
we be taught
Sorry.
how to will we be taught how to make this plan?
No. We are not actually getting certified for autonomous flying. We are only getting flying for RPAS. But I will explain you. I will show you, demonstrate something. But for that, you need a laptop to be managed. You need a telemetry devices, and all that things are required to prepare and fly the drone. But I will give you an example, and I will show you some demonstration about it, how that is being done. So normally these are being taught when you are doing a course for surveillance or monitoring or agriculture. When you go for like after you get the license, you are a licensed pilot and you want to learn how to do agriculture flight. You want to learn surveillance. In that those classes, we are going to introduce those classes also. Like we are already talked with our OEM for agriculture courses also. Okay, so where you can learn how to plan your agriculture missions. So once you are able to fly in one particular type of drone, you can easily upgrade yourself, or you can do the course also for that. Same thing it is. Okay, so once you can do it, or you can do it later on once you have your own drone or your learning plan. You can install a mission plan and all the things. You can connect the mission plan to the drone and you can fly it on your own also. You can do it on a simulator environment also. Okay. So global positioning system GPS module is responsible for provision of longitude, latitudes, and elevation points. So GPS basically is a device. It's a separate module which is there on the drone, which will give you the inputs like latitude, longitude, and the altitude at what height the drone is flying. Okay, it helps the drone navigate in VVLR. So as of now, we are having GPS devices on our drones, but it is not for VLS condition. It is only aiding our smooth flying. Okay, smooth flying, but it is not really useful. Without GPS, also we can fly the drone, but then we are manual. We will be completely manual flying. Now you are locking your drone in a hovering position because the GPS is there. Because of GPS, can be locked at that particular position. As I release my control structure, I leave my remote controller on the table also. My drone will keep on flying at that location. Why it is able to fly? Because the GPS coordinates are locked to that particular location. Until unless it receives any signal, it will not move. Okay. So GPS module helps in enabling the return to home. So now it knows. So the moment it take off from the particular location, that is RTH or RTL, okay, it will be know that that is the position. It will remember that position, that GPS coordinates. Okay, so that coordinate will be stored into the memory of the flight controller. The moment you trigger RTH or RTL, or the moment autonomously RTL or RTH has been triggered, it will automatically come to its RTH or RTL location. Okay, in case of communication failure or battery failsafe issue. So, do you think that RTH and RTL are different or they are same?
They can be different.
They are always different,
I
but
mean,
they can.
return to home would be the place where the drone launched from, And return to land would just
So
be
it is
it
not return
landing.
to land. It is
Okay.
return to launch.
Okay.
Okay. So return to home is one position and return to launch is one. First, understand return to launch. Launch is the position from where it take offs. Okay, from where it take offs. Okay. Whereas lot of time what we do, especially like in agriculture. Okay, agriculture line में क्या करते हैं हम लोग ड्रोन कार में से बाहर निकालते हैं, इको से बाहर निकालते हैं. Okay, we put it on a ground, we get it ready, we power it on. Okay, we check all the parameters, we fill the tank, everything. Okay, we do all the things, we do the calibration of the motor pump, everything we do at one position. So that position where I am powering the drone is my return to home. Okay. Now what happens when my field may be little bit away, 10 feet away. So I will not fly from the that location. I will take my, I would have plotted on my plan a start location. Okay. So मैं क्या करूँगा? I will pick up my drone from there manually and I will place it at the start location. Okay. Some location might be defined or some area might have defined where it has to launch and land also back. So that launch location would be there or start location would be there. So that will become my RTL because from that location I'm going to take off my drone. So that RTL will be the start location or the launch location. Whereas my home location was where I got my drone ready when my battery was connected first time. Okay, because I was calibrating or configuring my drone. So your home location and RTL location can be different, but they can be same also. For example, instead of powering my drone at the home location, I can always take my drone directly to the launch location, keep it there, and configuring it there itself, and I will fly it from there itself. So my home and launch location are same now, right? What the understanding of difference? So RTH and RTL are different, but most of the people do not use RTH. People always use RTL because RTL is the location from where your drone is taken off. Your home location could be anything. Okay, so you'll never, your home location can be always keep on changing, but your launch location will be fixed because the launch location is fixed with respect to the launch or takeoff. Okay, so you know from where you have takeoff, that is the safe location to land. Okay, so we'll always say return to launch. Power module, it's an input connector, so it's just a connector. So you will see there is a connector which connects to the battery side and there is a connector which connects to either to AC or to PDB. PDB is nothing but power distribution board. Since quadcopter will have 4 motors, you will require 4 ACs. Okay, so quadcopter will require 4 ACs. So you need 4 connections. So you will not have 4 connector coming from a battery connector. So you will have one common connector which will connect to the power distribution board, and then you will have a 4 AC connected to the power distribution board. Okay, so like this, you see here there is a battery connector connected to the battery to the power distribution board, and then you can see there are 4 connectors on 4 sides where you will connect your ESCs. Okay, so ESCs will be drawing power from each side of the connector. So in hexacopter you will have a 4 connections. In sorry, not in hexa, quadcopter you will have 4 connection. In hexa you will have 6 connections. Similarly for octa you will have 8 connectors. Okay, so basically, power module is nothing but it just regulates the power and it gives the signal to the flight controller about the battery status. So any given point in time, you should know, your flight controller should know how much battery is being there at the start, and as it is taking the flight, how much it's getting consumed, and what time it should indicate, or it should indicate the threshold values to the pilot. It will give you warning. It will tell you that okay, my battery is reaching 35% of voltage. Okay, as it reaches 30%, it will trigger. So it will tell you before actually initiating the action. It will give you the voice messages. So this all information is given because it is monitored. Okay, so voice voltage regulator will give inputs to the flight controller about the specification of the batteries, how much voltage is remaining, how much power is remaining. Okay, whereas PDB is a passive PCB, okay, or passive device where it just helps you to connect or solder multiple inputs or multiple outputs, okay, on the board. Okay, नहीं तो सब वायर एक साथ आपको tie करना पड़ेगा, which is very crude way of connecting the drone. So they have created a board called PDB, okay, power distribution board. Okay. Okay, so what are the applications of the drones in the various sectors? Agriculture, we have been using; forest and wildlife, we are using; urban development, we are using; healthcare, we have been seeing during the epidemic or pandemic. We have been seeing the drones have been extensively used for delivery as well as crowd control. That point in time, we have seen even in forest and wildlife, like in large areas like Africa, South Africa, Sahara. Even in deserts, where you have to monitor and keep a track. Of things. In those locations, also you have used drones. Agriculture, definitely we are using for crop health monitoring, soil health assessment, and improved resource utilization like fertilizer spraying, seeding. All those activity is basically an optimal use of your resources. ट्रैफिक मैनेजमेंट के लिए भी यूज होता है, होमलैंड सिक्योरिटी के लिए भी यूज होता है, डिजास्टर मैनेजमेंट के लिए यूज होता है, माइनिंग में भी होता है. So there is enormous applications are there, and we have seen the recent use case of the drones in the war also, right? Because of that, all the companies which are now have their share value gone up. Okay, business ideas for UAE industry, like a lot of students who join these courses for thinking that they will start some kind of a business or some entrepreneurial journey they would start. So you can start with aerial photography or videography, commercial inspection service. Like one of my students who has purchased a drone and he started real estate inspection services. Okay, so he can always provide those similar services for bridge, cell phone, tel towers, TV towers, power line towers, aircraft, railway, wind turbines, mines, oils and gas pipelines, solar panels. All this you can do under commercial inspection service. Survey and mapping. Land mapping is one of the biggest area which is going to utilize drones. So government is making sure that there will be a policy coming in now, okay, which will make mandatory that your all land mapping has to happen through drone. No manual mapping going forward. Okay, it will become a mandatory. So every time you will require a drone person or a surveying or mapping services to be available. Yesterday only I got one call from one of the company where they wanted to do a survey mapping done in Alibag region. Okay, so provide companies with 3D digital elevation, fencing data, survey construction sites for urban planning and development. Logistics we have already seen like Zomato, Swiggy, and Blinkit, right? They are already using. Similarly, Australia Post, Amazon are already started drone deliveries, medical supply, organ transportation. We have seen one of the case in Hyderabad where they have transported cornea or something from one location to another location within 20 minutes of time, right? So that is the optimal use of resources or drones for medical supply also. Even blood supplies also are done using drones nowadays. Okay, another more residential home inspections like roofs. Okay, exteriors of now we see a lot of high rise are big there, so a lot of time these glass panes get damaged. Okay, so you need to inspect them from outside and all the things. So even chimneys or structures or external damage inspections, lot of on the roofs, lot of structures, wind solar panels are on high rise buildings and all the things are there, solar uh, heaters and all those things are there on the oil house. So in that case, it's not physically possible every time to send a person physically and check all those things. So drones are coming into use cases for such kind of inspection service. Now, since you see the drone industry is going bigger and bigger, you need lot of shops, drone parts and repairs. So you will see, I mean, you see that there are hardly any drone shop available in our areas or anything. Okay, so this is one of the another opportunity. Like earlier, there was only one or two online options available where I can buy drone parts, but now there are at least 5 to 10 websites are there or e-commerce websites are available where I can buy drone parts, or even there are people who are available who can repair the drones also. So this will be another thing. So even we are in talks with our OEMs. We are already initiated that our flying zone will be also having a repairing what we say hub. Okay, so all the agriculture drones, instead of right now the agriculture drones from Marut needs to be sent to Hyderabad, from IoTech they need to be sent to Gurgaon. So which is not practically possible for the farmers from Maharashtra. So we wanted a local repairing hub to be started. So we are offered to these OEMs that we will give you the space, you set up the repairing hub at our flying location. So because after repairing you need to fly the drones for testing also. So they need a place to green field to fly their drones also. So that is the ideal place for setting up a repair location for those agriculture drones. So we have offered those opportunities to our OEMs. Then you can use for drone aerobatic shows or aerial advertisement. Again, these are a lot of companies have come up in this segment where they are doing, even night shows are being arranged by using drone flying or what we call as a swan technology. Okay, so these are some of the business ideas for your rotorcraft drones. Okay, again, data analytics, engineering consultancy, you can say, SaaS-based firms are there, or UAE insurance. Insurance company will also have jumped now. Initially, there was little hesitation, but after government push and all the things, now UAE insurance are being offered by a lot of insurance companies also. So these are all business ideas or business which have been created from the drone perspective. Okay, SaaS-based from software solution related to flight planning, control and driver seat. Like as I told you, we were doing monitoring of power line drones. Initially, our pilots were flying manually. Over the period of time, we found that manual flying is not a right option. So we approached one software company which will help us to create a flight plan, which helped us to create a structure. So in our flight plan, we had created a flight and we just uploaded in all drones. So the moment you give the dimension of your tower, the length and width and the height of the tower, automatically the flight plan was created. So drone used to fly as per the plan and automatically it will capture all the images I was. So my pilot intervention was zero. Pilot was only there to bring the drone out, power the drone, upload the flight plan, put the memory cards, and power it and execute. So we execute. The drone will fly, detect everything. It will fly the drone around the tower. It will capture and then it will safely land after whatever the parameters are defined. It will land. I will that point in time my pilot will only change the battery. He will check the memory card. If required, he will transfer the data and then again put the battery and again put the memory card and fly further like that. Okay, so only that activity was there. So the workload of the pilot has reduced enormously. Only he will be getting because we need to monitor in case there is some malfunctioning or some issue. As we are flying the drone closer to the power line tower, sometimes something because of the electromagnetic radiation, then possibility is there your drone becoming a rogue drone. Okay, or it may lose its control or something could happen because all these are electronic devices like GPS is there, telemetry devices are there. So you need to keep a control. In case of anything, the pilot has to take the control of the drone manually. So this we'll see in the today's topic in emergency handling. Okay. So with that, we complete our today's topic about the fixed wing and the rotorcraft. So we'll take a break. You want now to be taken a lunch break, or you want make a 10-minute break, and then we finish. I think we'll take a small break and then we'll do the hybrid so that all our
Yes.
and then
You are
we'll
not
start.
audible. You are not audible.
Sorry.
You are not audible.
Sorry, I am saying we'll take a small break now of 10 minutes. Then we'll complete the hybrid topic. Hybrid is just 10 slides. And then we'll take a longer break of a lunch break. After the lunch break, we'll start with our normal topic of weather and meteorology. Okay, then we'll talk about the drone equipment maintenance and then we'll do the what is that emergency handling. Okay, so these
Okay.
are the three critical topics left for our session.
Okay.
Let's take a small break. We'll join back at 12:50 or 12:55.
Okay. 12:55.